This is Mr. Roberts at Shasta High School, and we're going to step through the Chapter 8 study team test. So my intent is to go through each of these questions and help you kind of review and prepare for our test on Friday. Our first question asks us to solve a system of equations, and as I look at it, there's several techniques we have. Of course, there's equal values method, which is a form of substitution, and we've talked about elimination. The thing that I notice is that this is equivalent to 2y, right? So 3x minus 4 is the same as 2y. So it's a little different than what I normally do, but I'm going to go ahead and replace 2y in that top equation with this thing that's equivalent to 2y. So I'm going to write the following: 4x plus, and instead of writing 2y, I'm going to write 3x minus 4, and that's going to equal 10. So if I take this a step further, I'm looking at 7x minus 4 being 10. So 7x is 14. Oh, and x is the number 2. So I've got my x value, I believe. In order to find the y value, I'm going to go ahead and plug this value of x into, I think I'll use the second equation. So using this second equation, right, I can find y. Twice y is supposed to be 3 times whatever x is. But I just found that x was 2, and then minus 4. So this is 6 minus 4. That's 2y. So 6 minus 4 is 2. So this looks like 2y is the number 2. Therefore, y would have to be 1. So I believe our solution is that x is 2, y is 1. And of course, a quick check is always worth our time. So if I take 4 times x, that's 4 plus 2 times y, right? Y is, 4 times x. Uh-oh, that's not 4. Look at me, I'm making a mistake. 4 times the x value, x is 2. 4 times x is 8, plus 2 times 1 is 2, which is definitely the number 10. So it checks in that first equation. And then for the bottom equation, double y is going to become the number 2 based on my y value of 1. And then I've got 3 x's, which is 6 minus 4, 6 minus 4, and definitely 6 minus 4 is 2, so 2 is 2. So that's definitely my solution. Moving on to the next equation. Okay. Well, I think I'm going to take a moment to clean it up a bit, and maybe just knowing my first thought is always to get rid of the fraction. So I think I'm going to multiply this equation through by the number 3 to bust up this one fraction 2/3. So this is going to become 2x plus 6 times y multiplied by 3, and that equals 30. And then this equation, I am going to multiply both sides by 2. So it's going to become 2y minus 6 equals, now the right hand side is only one term, and when I multiply that by 2, it's just going to become the number 1. So it's this 1 that's going to be distributed to the x minus 6. So this equation says that 2y minus 6 is x minus 6. Okay. And if I add 6 to both sides, I get this. I get that 2y is the same as x. So what I've just decided, and I didn't decide it until this moment, was that I'm going to use this value of x as a substitution, right, in the top equation. So I'm going to rewrite this top equation, but instead of using x, I'm going to use the fact that x is the same as 2y. So that's going to be my substitution. So let's go ahead and take this equation and rewrite it. 2 times x, remember we're using this for x, so it's going to be 2 times 2y plus 6y is 30. So we're looking at 4y plus 6y is 30, or 10y is 30. Therefore, y is the number 3. And now that I know what y is, this tells me that x is going to be double y. So I think that x is the number 6. Now, based on everything I went through with that system, I definitely want to check this answer. So I think x is 6, and I think that y is 3. So I'm going to go ahead and plug things in for the first equation. So if this is 6, right, this is going to become 6 divided by 3 is 2 times another 2 is 4 plus, and 2 times 3 is 6, and that is 10. So that definitely checks. So it works in the top equation. Now let's check the bottom equation. Y is the number 3. So I've got 3 minus 3, which is 0. And we're wondering, is that the same as, oh, for sure. If I put 6 in there, 6 minus 6 is 0, and 0 times 1/2 is still 0. So it satisfies both of the equations. So the solution for the second system is 6. X is 6, y is 3. Let's move down to this problem. It says that the Shasta track team is selling boxes of candy as a fundraiser. Taylor ordered 4 small boxes and 1 large box for a total of $28. Chris ordered 3 small boxes and 2 large boxes for a total of $31. What is the price for each size box? Okay, so assuming everything's the same. So first of all, it says write a let statement to show which variables you are using and what they represent. So I'm not a fan of using s as a variable because every single time I write it, it looks like the number 5 to me, even if I'm careful. So I'm going to go with x and y. So I'm just going to say let x equal the number of small boxes, and I'm going to let y equal the number of large boxes. And based on the words up there, right, it says write a system of equations that you can use to find the cost of the small box, the small, and the cost of the large boxes of candy. Solve your system. Neatness matters a great deal if you expect me to, oh, yeah, try to be neat, and if you use an S, just be careful. Don't think that the S is a 5 at some point. So here's the thing I know. For Taylor's order, she had 3 of the small boxes. So I'm going to write 3. I've got a terrible thing here. I know how many she bought 3. I don't want this to be the number of small boxes. I want this to be the cost of a small box, and this is the cost of a large box. I'm so glad that I'm taking the time to write a let statement because that just kind of prevented me from making a big error. So this definition I'm happier with based on reading the rest of the problem, or reading the problem more thoroughly. So let's talk about Taylor's order. She ordered 4 small boxes. She ordered 4 of them, and each one of them cost X dollars. So 4X is the amount of money that she had to spend for the 4 small boxes. And she ordered just one of the large boxes, which is Y. So I'll say plus Y. And her cost was $28. Oh, I'm glad I caught that. Next, Chris, he ordered 3 small boxes. Okay, so three of the small boxes, each small box cost X dollars. So I'm going to say 3X plus 3 small boxes and 2 large boxes, so plus 2Y, and he had to pay $31. All right, so I've got 4X plus Y is 28, and 3X plus 2Y is 31. And I have to solve this system of equations, and apparently neatness matters. This system is not exactly immediately jumping out as elimination, but it's such a nice technique, I'm going to use it anyways. If I modify this top equation by just multiplying through by the number -2, it's going to create an excellent situation where my y's, I'll have a -2y in the top one and a +2y in the bottom, so those will eliminate. So I'm going to use elimination. So let's go ahead and write this top equation. after I multiply by the negative 2, it's going to become negative 8x minus 2y equals, I think if I double that, I'm getting like 56. 56. And that's the equation I'm just going to rewrite. This is a 3x plus 2y is 31. All right, so when I combine these, the 8x, negative 8x, and the positive 3x is going to equal a negative 5x. This is this is this is problematic. Oh, I know why it's problematic. Maybe you can see my mistake. I can see my mistake. When I multiplied everything in this equation by times negative 2, times negative 2, times negative 2, oops, I did not multiply this by negative 2. So I'm going to erase this, put a little bit more room here. This is supposed to be negative 56. Now, what triggered that in my mind? Well, I've seen over here that I've got a negative coefficient for x, and I know that the candy doesn't cost negative dollars, right? Great trick if you can do that. Guess how much this candy is? Well, we owe you money for every box you take. It's negative dollars. That's not what's happening. So I'm going to go ahead and take the number negative 56 and add 31 to it, and I get negative 25. Negative 25. And if I divide both sides by negative 5, I get that x is 5. So apparently the small boxes cost $5 each. I think we're going to check this at the end, but I need to figure out what the large boxes cost. And I'm just going to use, I guess I'll just use this top unmodified equation. Well, no, I'll use the bottom equation. So I'm just going to use this equation. So I'm going to say 3 times my value of x plus 2 times y is 31. So this is the number 15, right? So I'm going to take and subtract 15 from 31, and that gives me the number 16. So 2y is 16, therefore y is $8. So the cost of the large box, I believe, is $8. And the cost of the small box, I believe, is $5. So we've got those, I think. Now, of course, I'm going to check these, and I'm just going to check them by comparing it with the original problem. So it says Taylor ordered 4 small boxes. Okay, 4 of them. So I'm just going to go 4 times 5 and 1 large box, plus the large box price is 8, and I get $28, right? So definitely it checked for that first order for Taylor. And if I check with Chris, Chris ordered 3 of the small boxes, which is 3 times 5 or 15. Plus 2 of the large boxes, so plus 2 times 8, which should give me, and it does give me $31. So these both check, and I can see the cost of each kind of candy. Let's move on. Next, it says plot some points, okay, and connect them to form a triangle. So the first point is at T, which is negative 6, negative 1. The next point is at R, which is positive 2, positive 3. And the final point is at U, which is all the way at positive 3, negative 4. Okay, so I've got those now. I'm grabbing a physical ruler, and I'm going to quickly connect them to form this triangle. Close enough. Not too bad. And okay. And these points in this order were, this was point T, this was point R, and this was point U. And it says, first of all, determine the midpoint of segment TR algebraically and label the midpoint P on the grid. Okay, so it says algebraically. So if I wanted to algebraically, I can look at these 2 points, right? And I can see one is at T and the other is at R. So if I'm looking at this algebraically, I'm just going to add the x's for T and R. So I've got negative 6 plus 2, and I'm going to take half of that. And then for the x values, I've got a -1 and a +3. So I got -1 and then +3, and I'm going to take half of that. So this looks like -4 divided by 2. It looks like the x is at -2, and it looks at like the y is at 2 over 2. It looks like the y is at 1. And if I come over here and I look at this, I can see, oh yeah, x is -2 and y is -1. So this point is the midpoint, and it is at 2 or -2 for x and 1 for y. And I can see it here as well. This is the point P. They said label it as point P. And I can see that it's a midpoint another way too, besides this algebraic technique. If I move up 2 and then over 1, 2, 3, 4, and then up 2 and then over 1, 2, 3, 4, because that slope pattern well, the slope is a half, right? But those triangles are 2, 4, and 2, 4. When I calculate the length of these individual hypotenuse, like this one and this one, they're going to be the same number. So P is definitely at the midpoint, completely convinced of that. The next thing we're asked to do is find the distance between points P and point U. Okay, let me grab green. And we're asked to find the length of this line segment. Oh, I don't know why I erased it. This line segment. So looking at this, right, I want to find a right triangle in which that would be the hypotenuse. So I'm going to look at the following. I'm going to look at this, and I'm going to go down here. So this is most helpful because the lines that I just drew were vertical and horizontal. I know this is a right angle for sure. And if I count this vertical line, it's 1, 2, 3, 4, 5 units long. And the horizontal line is 1, 2, 4, 5 units long also. And I can see that the slope is -1, right? 5 over -5 over 5 is down 1 over 1. But I don't care about the slope. What I care about is the length of segment PU, right? So how long is this segment from P to U? So this is what we're trying to find the length of. And if I arbitrarily say, well, I'm just going to call that, I'll call it D. I'll just call it D. I'll say that variable D, I'm just going to call it D arbitrarily. I know that if I take D and I square it, it should be the same as the one leg in my right triangle squared plus the other leg in my right triangle squared. So I'm looking at 25 plus 25. So what I'm looking here is that D squared should be the number 50. And if I take the square root of D squared, I get D is, and the square root of that, I can either write it as root 50, clearly, right? Simplified radical form, this is the same as 25 times 2, so I can bring out the matching factors of 5 out front and write 5 times the square root of 2. Or I could convert it into a decimal approximation also. But the length of segment PU is 5 times the square root of 2. Okay, final question here. It says, I'm supposed to find the area of triangle TRU. Okay, that's the entire original triangle. So I'm just going to kind of highlight this in gray. So this is TR. Oh my gosh. Here we go. So when I'm asked to find the area of something like that, and I look at this triangle I have, it's not a right triangle, I don't think. I don't think I have opposite reciprocal slopes anywhere. I don't think I could find the area, because I don't have a base and a height. That's not available. So what I'm going to do is I'm going to resolve this dilemma by looking at a rectangle that bounds the entire thing. I'm using a lot of the same colors, so let me pick this green and I'll make it this, I don't know. Pick a color, Roberts. Okay, I don't like any of these colors. I'll pick this color. So what I'm going to do is I'm going to look at a rectangle that bounds this entire shape. So looking at the extremes here, I can see that this rectangle and this color I've picked doesn't even show up well, completely bounds all the vertices of this triangle. All of them are going to be included in it. So what I have to do is I have to find the area of this rectangle, and then from that I'm going to subtract some things, right? I'm going to subtract the things I'm going to serve. I need to take this away, I need to take this away, and I need to take this away. And I just mark those like that. So if I take those three triangle areas away from the entire rectangle, I'll have just the area that I need, which is this triangle inside. Okay, so let's figure out what's the area of the big rectangle. If I look at that rectangle, I think it's 4 plus 3, I think it's 7 tall, and then I'm going from, this is 3 to negative 6, and it's 9. So the 9 times 7 gives me the 63. So I'm looking at the area is going to be 63 minus a few things, right? Minus a few things. The first thing I'm going to subtract is the area of this particular little right triangle right here. And I like this because I know that the base of this is 1, 2, 3, 4. This is 4 units long. And this is 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8 is 32. And that makes this have an area of half of the 32, or 16. So from the 63, I'm going to subtract 16, right, which is the area of that first triangle. Let's do this little skinny one over here. So this one just has a base of 1, and then the height of this one is 7 still, right? So it's 1 by 7. 1 times 7 is 7, and then half of that is 7 halves, or 3.5. So I need to subtract 3.5 also. And then the last value I need to subtract is the area of this triangle. This one is 3 tall, and it's, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9 is 27. And half of 27, what is it, 13 point something, 27 divided by 2 is 13.5. So that's the final one I'm going to take away. I'm going to subtract 13.5 from both sides. So, or from the full area of 63. So on my calculator, I'm just going 63 minus 16 minus 3.5. And then minus 13.5, and I get an area of 30 units squared. So that's just showing it's an area, units squared. Now that I mentioned that, I probably should put up here that this was 5 root 2 units. Because I don't think the problem ever said how long this grid was. I don't think it said it was inches. So I've got a length of 5 root 2 generic units for the length of PU, and the area of that triangle is 30 units squared. All right, let's move on to the next problem. So I'm going to choose to do the geometric sequence first because it's the thing that's, well, a little bit newer for us. So let's talk about this. So I can see that the second term in this sequence is the number 5103, and the 6th term is 63. So I can see that they're getting smaller, and I'm told that it's not linear. I said this is a geometric sequence. So I know that I'm going down, I'm getting smaller by multiplying. And if I count my steps here, it's 1 step, 2 steps, 3 steps, 4 steps. And I can also get that by just looking at the fact that the 6th value and the 2nd value are known to me. So 6 minus 2 is 4. So I start with the number 5103, and I multiply it by several b's. How many b's? 4 b's, right? So 5103 times a b, 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 b makes it become the number 63. And looking at this from a table, this really reduces the complexity of this problem to me. What I'm going to do now is I need to get b alone eventually, but first I'm going to get b to the 4th alone. And I know that b to the 4th has to be the same as 63 divided by 5103. You can see all I just did was divide by 5103. And then for my final step, I'm going to raise both sides to the 1/4 power. And again, my thinking is that if I have b to the fourth and I raise that to the 1/4 power, right? A power to a power, 4 times 1/4 gives me just plain old b. But I'm going to do the same thing over here. I've got 63 over 5103, and I'm just going to raise that to the 1/4 power. So on my calculator, I'm going to go ahead and enter the number 63 over 5103. Actually, I can show you my calculator, I think. I think some of you might like to see this, or some of you may not. Let me turn on the calculator. Yeah, there it is. So I could go, what did I say? So 63 and over 5103. So I entered it as a fraction, and it does reduce to 1 over 81. I need to take this number and I need to raise it to the power of 1/4 to figure out what b is. So I'm just going to take this. I'm going to say raised to the power of, right, this up arrow, of 1/4, 1/4. I hit 1/2, 1/4. And when I do it, it gives me that b is 1/3, right? So now that I know b is 1/3, I know my multiplier, right? And kind of as check for that, it's kind of nice to enter 5103 on your calculator, 5103. And if you enter 5103 on your calculator, you can then hit times, right? So I've got this on the, I entered this, and I've got times 1/3. And if I go 1, 2, 3, 4 jumps, you can see that it definitely makes it become the number 63. So I clearly know my multiplier. And if I want to figure out what my 0th term is, I can figure that out just by going backwards twice. So instead of multiplying by 1/3, right, I'm just going to multiply by 3 twice and get my 0th term, which is the value of a. So if I'm looking at this calculator again, I've got the 5103, and then I'll go times 3, and then I'll go times 3. And it gives me 45, 927. So I think my answer is y is equal to 45, 927, 45, 920, 45, 45. There it is. 45, 927 times 1/3 raised to the x power. And, you know, a good practice is to, hey, plug in 2 into that equation and make sure you get 5103, and then maybe plug 6 into it and make sure you get 63. So maybe I'll do that. I'll plug 6 into that and make sure I get 63. So there's that number. I can just go up and grab that number, and I'll just go times 1/3. And I've left my fraction, so I'm just going to raise just this fraction to the 6th power. And it became 63. Looks good. All right, so now let's do the one that was arithmetic, right? So write an equation in the form y equals mx plus b. So it's going to be an arithmetic equation, or it's going to be an arithmetic sequence, right, which can be modeled with a linear function. So I've got this y equals mx plus b. And if I just take a look at this, I can see that I go from 1 to 8, which is a difference of 7 units. So I'll just go 8 minus 1 is 7. And I do that in 1, 2, 3 steps, or 4 minus 1 steps, right? I do it in 4 minus 1 steps, which is 3. So what that means is that I have to be adding 7/3 each time, right? So that is my slope. It's what I'm adding each time I move forward. And my 0th term I would get by just taking 1. I just take the 1, and I would subtract 7/3 from that. So that would be, let's see, the number 1 is the same thing as 3/3. Yes, and 3/3 minus 7/3 would be negative 4/3. So this should be negative 4/3. And if I kind of step through this on a calculator, oh, I am so sorry. I didn't switch back to this screen. I'm sorry. That's unfortunate. You were just looking at my calculator the whole time. Anyways, what I was, bad job, Roberts. Maybe I could do this. I could undo. No, it lost. Oh, maybe not. So you can see I just did 8 minus 1, and I got that that was the number 7. And then I did 4 minus 1, and I got that that was the number 3. So I know that I'm growing by 7/3 each time I'm adding 7/3. And then to figure out what my 0th term is, I just take 1 and I subtract the 7/3. Instead of adding it to go backwards, I subtract 7/3. And then 1 is the same as 3/3. And 3/3 minus 7/3 gives me negative 4/3. So I've got the value of my 0th term, and I know what I'm adding each time. So the linear equation, let's just go ahead and write it down, should be of the form, whoops, I don't know why it should be y is equal to adding 7/3 times x minus 4/3. So that should be it. And if I want to just do a quick check, I guess, I'll do the following. Now I'll go back to that calculator. I'm going to enter my 0th term on here, so negative 4/3. Press enter, and I'm just going to say plus 7/3. Now if I do it once, I should get the number 1. Yeah. Second, third, the 4th term should be 8, and the 4th term is indeed 8. So that was me just showing this. I got to make sure I'm on the right screen. So that was me just showing that. So yes, the number negative 4/3 does grow up to the number 8 in that many steps. So it's just a little check. Another way you could check is just plug 4 in for x and make sure you get 8. And if you plug 1 in for x, make sure you get 1. And if those both work, you have a nice check for that. Let's move on to our next page. Okay. A great observation, right? A great trick. Remember, negative exponents are not negative numbers, right? Negative exponents are just reciprocals. So if I was to look at something ridiculous like the number, I'll just do 2/3, and I raise that to the power of -1, notice what it does to the 2/3. It makes it 3/2. You see it flipped it, right? It's reciprocal. And if I took that 2/3 and maybe instead of, I'll do this. I'm going to raise the 3/2 to the -2 power. So watch what this is going to do. It's going to flip it, right? It's going to be 2/3, but it's also going to square both of the parts. So all of a sudden, this is going to become 4/9, right? Notice what was the denominator 2 became the denominator, or numerator squared. What was up in the numerator became the denominator, right? 3 squared is 9. So with that observation, it's kind of safe to say, we can assume maybe, that if you see a fraction raised to a negative power, right, there's a quick change up you can make. This is going to be equivalent to 3x over 2x squared to the positive 3rd power. There's another thing I could do just looking at this, just looking inside the parentheses. I've got an x over x squared. So if I look just in the parentheses, that x over x squared can be simplified to 1 over x. So I can write this as 3 over just plain old 2x, and it's still getting cubed. All right, so again, I just use this idea that if I have x over x squared, right, that's the same as x over x times x. It's just 1 over x. All right, so now what I have to do is cube this thing, which means I have to multiply 3 times itself 3 times. So I'm going to have 3 times 3 is 9, times another 3 is 27. So the numerator becomes 3 times 3 times 3, which is 27. And the denominator becomes 2x times 2x times 2x. And if I look at those, let me write that. If I look at those, just the numerical parts, that's 2 times 2 times 2, which is the number 8. And it's x times x times x, which is x to the 3rd power. So this is 27 over 8x cubed. This next one, I can see I've got positive exponents for b. It's b squared over b to the third. So because I've got 2 factors of b in my numerator, 3 factors of b in the denominator, this is going to be the same as a squared over a to the negative third times b. So that's what b squared over b to the third is. It's just a 1 factor of b in the denominator. The other thing, and I was really happy to see some of you do this on the study team test, if I multiply the top and bottom of this by a to the third over a to the third, this has the very positive effect. When I multiply a to the negative third times a to the positive third, that's a to the 0 power, which equals 1. So what's happened is I no longer have any factors of a in the denominator. I just have 1 times b. In that numerator, so 1 times b is just b. That's all I've got in the denominator. In the numerator, I now have 1, 2, 3, 4, 5 factors of a, or a to the 5th power. Let's do d since we're here. Looking at d, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors of a. This is a to the 10th, and that's getting cubed. A to the 10th times a to the 10th times a to the 10th, that's 30 factors of a. So this is a to the 30th over a to the 20th as being up a to the 20th. And when I have a situation where I've got 30 factors of a in the numerator and 20 factors of a in the denominator, 20 of those are going to pair from the bottom with 20 on the top. They're all going to cancel. I'm going to be left with just a to the 10th power. 30 minus, another way of thinking about 30 minus 20 is 10. So there's only going to be 10 factors of a in our final answer. And then let's back up and do c. Okay, so for c, this is a to the first, and this is a to the negative second. And if I multiply those two together, I'm going to get a to the negative first. And I could stick that in the denominator if I want to, but I'm going to leave it there for now. And then I've got this b cubed. And then the other thing is I've got 2a to the 4th power. So that is 2a times 2a times 2a times 2a. Or I could think about it this way. That's going to be 2 to the 4th power times a to the 4th power. 2 to the 4th power is 16. That's 2, 4, 8, 16. So I've got the number 16. And then when I look at this, I've got a to the negative 1 and a to the positive 4 power, right? So that's the same as a to the 4th over a to the 1st, or it's just a to the 3rd, right? So my final answer looks like 16b to the 3rd, and then I apparently have 3 factors of a also. So I'll write this here, 16, I'll go this order, a to the 3rd, b to the 3rd. Moving on. Next, it says, write the equation with a line that goes through some points. Okay, some points. So let me calculate my slope first. So for me to calculate my slope, I'm going to go ahead and take, I don't know, I'll take negative 3 minus 5, negative 3 minus 5, which is going to give me negative 8. So that's my change in y. Apparently y went down. And then I'm going to go ahead and take the 7 minus 1, which gives me 6. So I think my slope reduces to negative 4/3, right? Both of these are divisible by 2. So it's negative 4 divided by 3 when I divide them both by 2. So that's my slope. And it doesn't specify the form of the equation I want, so you're totally free to use point slope form. So you could write, for example, y minus my y known value of 5 equals my slope, negative 4/3, times the quantity of x minus my known value of x, and that's perfectly fine. You can also write, if I use that other point, I could write y minus negative 3, which would be y plus 3, is equal to negative 4/3 times the quantity of x minus 7. Yeah, x minus my known x value. Either of those are great. If you were to, solve for b, which is, it's nice to know. Actually, you could just rewrite either one of these in y-intercept form and you'd have the answer too. Let me do this just to check my answer with the answer I've written down on a key. So I'm going to add 5 to both sides, and I'm going to distribute the negative 4/3. So this is going to be negative 4/3 times x plus 4/3, right? Because I've got negative 4/3 times negative 1, and then plus the number 5. So the question is, what do I get when I add 4/3 and 5? Well, 5 is the same thing as 15/3. So what I'm looking at here is 4/3 plus 15/3, which is 19/3. So also, this is a great answer. Y is equal to negative 4/3 x, and then plus 19/3. That was fun. Let me put a smiley face there. Next, what is the slope of any line that is parallel to the line you found? Oh, okay. I just found this line at a slope of negative 4/3, down 4/3. Any line that would be parallel to it, right, would have to have a different y-intercept, but it would have to have the same slope. So the slope of any parallel line would be exactly negative 4/3. And what is the slope of any line that is perpendicular to the line I found? Oh, that would have to be up 3/4. So for a perpendicular line, the slope would be 3/4. Beautiful. Next, solve for x. Okay, I want to do this one first. The next one looks really fun, but I want to do this one first. And I'm going to do this by what? I'm going to multiply both sides by 6, right? So this 6 will destroy all these fractions, and it's 6/1, and it has to be each term on both sides. And I can see I've got 1, 2, 3, right? This is one term. I'll circle it. This is one term. Even though it's complex, it's one term, it's a fraction. The numerator has 2 terms, the denominator just has the 3, but it's just one term. And then I've got another term here. So each are going to be multiplied by 6. 6 divided by 2 is the number 3, so this is going to become 3 times 3x, plus 6 divided by 3 is 2, so this is going to become 2 times 4. On the other side, 6 divided by 3 is 2, so this is going to become 2 times the quantity of 3x minus 2. And then finally, 6 divided by 1 is 6, so this is going to become the number 60. So I'm looking at 9x plus 8 is equal to 6x minus 4 plus 60. If I subtract 6 x's from both sides, I've got 3x plus 8 is positive 56. I'm going to take away 8 from both sides. So 56 minus 8 is going to give me the 48. So 3 times x is 48. And then finally, if I divide both sides by 3, 48 divided by 3, it looks like x is the number 16. And it's probably a good idea to check that. I'll remind you of a technique we have for checking equations, right? One of the things I could do is I could take this calculator, and it does a great job of allowing me to store what I found x to be. So I think x was 16, so I can say 16, store that in x, boom, right? And I can clear it, but at this point, whenever I hit this variable button, x, this calculator says, oh, x, you mean 16, right? If I say 2x, it's going to give me twice 16. So it believes, because I told it, that x is 16, right? Well, now, what that gives me is the ability to type in the left-hand side and the right-hand side easily. So I can just write 3x over 2, right? And then I had plus 4/3, plus 4/3. And when I do that, you can see I just was typing this chunk of the equation in, right? 3x over 2 plus 4/3. And when I do that, my calculator gave me the number 76/3, right? So I like to write this down somewhere. So I'm going to write, I just got 76/3 from the left-hand side. And the question is it the same as the right-hand side? So let's go check that out. To check that out, I'm just going to go ahead and type a fraction in the numerator. I'm going to type 3x, no, I'm going to type a fraction with 3x minus 2. In the denominator, I'm going to place the number 3, and then I'm just going to add 10. And I get exactly 76/3 also. So because the left-hand side and the right-hand side were both 76/3, right? Hey, it checks. That is definitely our solution. Let's move on to the other problem that I guess strategically left. So one of the things I want to caution you about is that if I look at this numerator has 2 terms. Those are not factors. And the reason why that is kind of important is if I had, for example, like 3 plus 5 over 3, that is not equal to the number 5. It's equal to 8/3, right? So remember, when we see things like this, we can't cancel common terms, right? We can only eliminate common factors. In fact, if I switch this so that these were factors, you can see my top is now, the numerator is now 3 times 5, 15. And 15 divided by 3 is indeed 5. So you can see this does form a giant 1, and it becomes just the number 5. So no such luck here, though, because these are terms. However, we can use fraction busters, and it looks a little complicated, but what would eliminate these fractions are the following. I'm going to require an x, and I'm also going to require an x minus 3. Over here, I'm going to read both sides, right? An x and an x minus 3. And again, when I talk about fraction busters, I'm just looking at the denominators that I see, and I see I need a factor of x to eliminate these fractions, and I need a factor of x minus 3. And when I do that, over on the left-hand side, right, there's this x divided by x, which, well, that's fun. It erased it. I didn't know it would do that. There's this x over x, right, which definitely becomes a giant 1. So that's gone. So what I'm left with on this side of the equation is x minus 3 times that entire numerator, which is x plus 1. And then on the other side, the x minus 3, right, is a common factor with this x minus 3. So those are gone. So x minus 3 over x minus 3 is equal to 1, right? It's exactly the same things. It's gone. But what I'm left with is an x times the quantity of x plus 2. So x plus 2 times the quantity of x. So this right-hand side, simplest form of the distributive property is x squared plus 2x. Over on the other side, it's a binomial times a binomial, right? We can write this down. It's x squared, and then it's plus an x, and then it's minus 3x, and then it's minus 3. So if I combine that, it's x squared minus 2x minus 3. And on the other side, it's x squared plus 2x. And if you ever get a little, or if they get ugly, right, you can always use a generic area model and just look at, hey, I'm multiplying x minus 3 times x plus 1. And each one of these 4 things gives me a part of what I'm seeing in this product here. So this is the x squared, this is the 1x, this is the minus 3x, and this is the number negative 3. So they're all there, they're visible. Final step, I guess I'm going to, they both sides has an x squared, so I'll subtract x squared from each side. And then I'm left with negative 2x minus 3 is positive 2x. So I'm going to add 2x to each side. I'm going to get that negative 3 is 4x. Therefore, negative 3/4 should be the value for x. And again, you know, I've got it here. I've written it down, but you know how I feel about my work. If I'm wrong, I want to know I'm wrong, and I want to have a chance to look and see if I can find my error. So I'm going to go ahead and in my calculator, I'm going to store negative 3/4. So I've got -3, oops, -3/4, and I like to press enter, and I'll store that as x there. I've just told it what I believe x is, and I'm going to type in both sides. So if you remember, the original equation had an x plus 1 over x, right? So I'm just typing in the x plus 1 over x. So in a fraction, I'm going to have x plus 1 over the number x, and that gives me a -1/3. So when I plug this in, this side, the right-hand side, gave me a -1/3, and the question is that the same? Oops, that was the left-hand side. The left-hand side, is that the same as the right-hand side? And then for the right-hand side, I'm just going to type in a fraction again with an x plus 2 in the numerator and an x minus 3 in the denominator. And I also get -1/3. So because both sides of that equation produce -1/3, right, I'm certain that that is a solution. What does that mean? I found, excuse me, I found a value of x that makes both sides the same. So, yay. So my answer is x is -3/4. All right, so we're on the last page of the study team test, and question 8 asks us to find the equation in the form y equals ab dx that would pass through two given points. And I know that based on the form of this equation, right, it's going to be an exponential curve that would have an asymptote at the line x equals 0. No, I'm sorry, y equals 0. And I've set this up one of the ways that we talked about it in class, where you solve it by treating it like a systems of equation. So you can see I've taken the y values of 156 and 20, and I placed it where y is in the equation. And I've also taken my x values of 3 and 10, and I've placed those up where the x's are. So this gives me two equations, and the two unknowns happen to be the parameters that I need to find, a and b. So I'm going to solve this system by using the equal values method, or maybe substitution, I don't know. I'm going to get a alone in this top equation. So to get a alone here, I'm going to divide both sides by b cubed. So I'm just going to write 156 over b to the third power is what a is. And actually, I'll go equal values, and I'm going to get a alone in this equation also. So to get a alone here, I'm going to divide both sides by b to the 10th. So this is going to become 20 over b to the 10th power is also a. So if I set these two expressions that are equal to a equal to each other, right? First a is equal to the second a, I get the following. I get 156 over b cubed equals 20 over b to the 10th. If I want to bust up these fractions, I would multiply both sides by the minimum number of b's, minimum number factor of b's, to make all the b's run away like they're scared kids on Halloween at knocking on my door. So I'm going to multiply by b to the 10th on both sides. On the left-hand side, b to the 10th divided by b to the third is going to become 156 b to the 7th power. And over on the other side, b to the 10th divided by b to the 10th is just going to become the number 20. Next, I'm going to get b to the 7th alone. So b to the 7th is 20 divided by 156. And again, same thing, I'm going to raise both sides to the 1/7th power to get b alone. So b to the 7th to the 1/7 is just going to give me b. And over here, I've got 20 over 156 raised to the 1/7th power. So let's take a look at that on our calculator. The fraction is 20 over 156, 20 over 156, boop, which I guess reduces to 5/39. But I need to raise that to the 1/7th power. So I'm going to say to the power of 1 over 7, boop. And this is my multiplier. That's my value of b. And it does say up here round a and b to the nearest hundredths. So 10th, 100th, so 2 decimal places. So if I was going to round b to the nearest hundredth, according to my calculator, b is approximately 0.75. I just wrote that down. B is 0.75. So that is my apparent multiplier. And I need to get the value of A also. And in order to get that value of A, I'm not going to use 0.75. I'm going to use the value of B that's on my calculator, right? And I'm going to plug it into either one of those equations. It doesn't matter which one. I think I'm going to go ahead and choose and use the bottom one. So I'm going to just take 20 divided by b to the 10th power. And just notice how I manage this. So I've got 20, and I need to divide that by. Now, I'm going to go up 1 and grab b. So if you look, what do I have? I've got 20 divided by b, and that b has to be raised to the 10th power. So 20 divided by b to the power of 10. And when I do that, it gives me that my value of A should be 376.23 if I'm rounding to the nearest tenth. So 376, so A is, let me go back over to this screen, 376.23. So that means, I believe my answer is the following. Y is equal to, by the way, to the nearest hundredths, tenths, hundreds, 376.23 times A, which is 0.75 to the power of x. And I almost ran out of room for that, but that's very important that you get the power of x up there. So that is an equation that will attempt to give me 156 if I give it 3, and it'll attempt to give me 20 if I give it the number 10. Okay, so for the last problem on this page, actually the last problem on this test, we have 3 polygons, and each pair are similar to each other. That means they're the same size with different shapes, same shape rather with different sizes. And we're asked to find the value of the piece labeled with the question mark. So if I go from this 12 to the number 8, right, what I'm multiplying by is I think I'm multiplying by 8 12s. I think this is my scale factor if this is the direction, like from the big to the large. So if I was to just as a test multiply 12 times 8 12ths, you can see it becomes 8. So this 8 12ths is my scale factor, and all I'm going to do is I'm going to take the number 9, and I'm going to take the number 9 and I'm going to multiply it by 8 12ths. And when I multiply 9 by 8 12ths, this is sloppy arithmetic. I mean, there's a factor of 3 there, but I'm just going to go ahead and grab 9. 9 times 8, of course, is 72. And if I divide that by 12, I get the number 6. So this, right, this question mark would be 6 units long. So that's A. For B, I see from here to here, okay, that's a nice scale factor, right? So if I just take the, again, I'm taking the new and dividing it by the old. No. So I've got 12, the new, the 6 times what becomes 12? Oh, 6 times 2 becomes 12. 12 divided by 6 is the number 2. The scale factor is 2. 6 times 2 is 12. 4 times 2 is 8. So this one should be 8. And then the final question has, I'm asked to find this. So let me see if I can figure out the scale factor. If I go from 16 to 4, 4 over 16 is 1/4. So I'm multiplying by 1/4. And if I take 24 and I multiply it by a fourth, that's 12 at 6. I believe this one is 6 also. So looks like we're going to wrap that up. Those are all of our answers to the study team test. I tried to be, kind of slow and methodical so that you can get a clear picture of what's going on. If you have any questions you'd like to discuss with me before the test, please stop by room 309. 309? Yeah. And we'll chat. Have a good time preparing. I'll see you in class.